Okay, so today we're going to start section 2 of chapter 5. However, we will not finish it today. Today we're just going to learn how to switch from exponential form to logarithmic form, back and forth, and then we'll also see how to simplify or solve for the variable. Now, tomorrow we'll do the graphs of the log functions. And again, we're going to do a chart like we did for the exponential. Now, for this chapter 5 test, we're going to be breaking it up into 2 parts. You'll have a calculator portion and a non-calculator portion. Right now, the first part, which will probably be the calculator part, will probably be a week from tomorrow. And then the second part will be the following week. That's what we're shooting for. I know next week is early release, but again, it's just a calculator part and it won't be that long. So several years ago, when I first was teaching this to some of my classes, I struggled with a good trick or something to help students remember how to convert from one form to the other. So I always like to look for little acronyms or something to help. So I came up with the idea of coming up with the acronym BAY. So if you think about it, what's happening here, the exponential function and the log function, they're inverse functions. Just like back in middle school, you probably learned that the inverse or the opposite of addition was subtraction, and the inverse of multiplication is division. So here, the inverse of the exponential equation is the log equation or the log function. So if you ever heard opposites attract, the bay of the exponential function is the log. So what I found was everybody understood when I had an exponential equation, because you've seen those before. So for example, if I told you 2 to the third power equals 8, I knew everybody understood that the 2 was the base. So that's going to be the B in my acronym. The 3 is the exponent. And then the 8 was the answer to the problem. So when it's in exponential form, it's spelling the word B, like the name B. So then when you want to put it into log form, we're going to spell the word bay. So what we're going to do is take the log, then the base of the exponential would go here, then the answer, and then the exponent. And it doesn't have to be a capital A, but then we're spelling bay. So we go from a B to a bay. Now, in some books, they tell you, do like a semicircle, rotate the powers, whatever trick's going to help you. But one thing to remember, that this base of the log function is always the same as the base of the exponential. And then essentially all we're really doing here is switching the answer and the exponent. But if it helps you to remember the acronym BAY, when you switch from exponential, it's spelled out as B, the name B, and then when you go into log, you're going to put in the numbers and spell the word BAY. So over here, this is an example of a log equation, and this would be the exponential form. So what we're going to be doing is switching back and forth. We'll be switching from something that's given to us in log form, and they may ask us to switch it to exponential, or it may be initially given it to us in exponential form, and they're going to ask us to switch it to log form. When we go to solve these equations, if you can't solve it the way it's given to you in whatever form that may be, then try switching it to the other form. So that's going to be the main idea here. So if it's given to you in exponential and you can't solve it, switch it to log. It may be something that you could apply a property to and then solve it, or vice versa. If they give it to you in log form, maybe you can switch it to an exponential form, and then you can use the skills we learned in 5.1 to solve that exponential. Now, if you recall, the graph of the log function, and again, we're not graphing today, or the graph of the exponential function looks something like this. It went through this order pair right here at 0, 1, and remember it went up like this. This is the exponential graph, and what you're going to find is we would have this imaginary line here of y equals x, and the graph of the exponent of the log is like a reflection. So it would look like this. So this would be the graph of the log. But again, we're graphing the log functions tomorrow. So it's symmetrical across this line of y equals x. So let's go ahead and look to see how we're going to convert from log to exponential or exponential to log. And I'm going to be using my little Bay trick to help you do it. So let's look at our first example. So here it wants me to, if it's given to me in a log form, I want it to switch now to an exponential form. And so what we're going to do is I'm going to take the letters. So the 2 is my base. I'm spelling the word bay here. Then the 8 is the A, or the answer of the exponential, and this will be the power. So I'm going to take the base, put the exponent, the E, and then put the answer. So now when I go from bay to move it to exponential, I'm now doing B. Now, if it's easier for you to just see that this base is the same, and then these two switch places, you can do that as well. Now, once you convert something from log form to exponential, this exponential equation that you just made, it needs to make sense. If 2 to the 3rd power did not equal 8, then you've done something wrong. So it's easier to check your work when you're going to go from log to exponential, because you can solve this one. Now, as far as going the other way, you would have to use your calculator. There's other ways to do this. If you don't like my Bay trick, you can do semicircles or half turns or whatever trick's going to help you to remember the places that you have to put the numbers. But always remember, the base of the log is always the same as the base of the exponent. So over here, if I use my Bay trick again, the 1/2 is my base. The 16 is my answer. I'm spelling the word bay. And now I'm going to put it into exponential and then spell B. So put the base at the base, put the exponent up here, and then put the answer. And again, we could check this. Remember, whenever you see a negative exponent, think reciprocal. So I could evaluate 1/2 to the -4 power, turn this into its reciprocal, and now raise it to the 4th power. And 2 times 2 is 4, times 2 is 8, times 2 is 16. So the equation that I just wrote, it checks out. I did place the numbers appropriately. The next one, again, all we're doing is switching forms here. So B, if I spell it out, B-A-E, and then again, I'll put it base, exponent, and then the answer. And again, 10 to the 5th power is 100,000. Let's try the next one. Now we're going the other way. So remember, right now, the 5 is the base, the 2 is the exponent, and the 25 is the answer. So when it spells B, when I go to log, I'm spelling bay. So log, same base, it's a 5. Then I take the answer and then equals that exponent. So I just spelled bay when I went the other way. The next one, same thing. It's exponential. I'm going to log. So again, this is right now, the way it's written here, this is exponential. So this is the base. This is my exponent. This is the answer to my problem. I'm now going to transform it and do bay. So this is what I'm putting it in. So then here it becomes log 3, 1 over 81 equals -4. Now, one thing to remember, that this base of the log and the number you're finding the log of, this can never be negative. Can never be a negative number. The answer to your log, this one can be negative. So just little things to look at. All right, next one. Anything to the 0 power is 1, and we're going to see this coming up as a property, but we'll go ahead and transform it. This is the base, the exponent, the answer. It's in exponential form. So log of 3/4 of 1 equals 0. Again, all we're doing is switching the numbers around. Next, we're going to learn some properties of logs, and this is going to help us when they want us to solve for the variable now. So let's go ahead and take a look at the properties. So here, I just used this one. Here, the property that you'll memorize is that the log of base A of 1 is always going to equal 0. Because again, if you transform this to exponential, anything to the 0 power equals 1. So even if you did 100 to the 0 power, it's always equaling 1. So this would just be what the exponential equation would look like. So it's a property. So anytime you see, let's say the problem was find log base A of 1, find out what the answer is. Well, as soon as you see this, you should know that this x is going to equal 0. You're going to apply the property. Now, you could put it in exponential form if you need to see it. So again, we would take the base, and then we would, so again, remember we're spelling bay here, B-A-E. So I would do a to the x equals 1. And then as soon as you see that the answer here was a 1, you should know that this x needs to be a 0, because anything to the 0 power is 1. The next one says log base A of A equals 1. And again, if you transform this to exponential and do your BAE, so base, answer, exponent, A raised to the first power, anything to the first power is itself. So again, you could transform it to exponential if you need to see that. This little 1 should have been the power. Little typo there. The next property. Here, whenever the base of the log is the same as the number that you're trying to find the log of, when these are the same, what's going to essentially happen is this is going to sort of cancel out, and then you're just left with what x equals. So let me show you putting this in exponential form. So again, if I do the B, A, E, this whole thing here is the answer. So what we're going to do here is A raised to this exponent equals this answer. The next thing that's missing here, notice the word and. So this was missing part of the notes. So what you need to fill in here, and when it's in exponential form, A raised to a log base A of x, this also equals x. So again, these are inverse operations. So whenever the base of the exponent is the same as the base of the log's exponent, then these would cancel out, and then you're just left with x equals x. So little things that you're going to see as we try to simplify these. So let me show you one with numbers. So let's say it was log and this is applying this over here. So let's say it's log base 3 of 3 to the 4th equals x. If I turn this into exponential, again, this is the base. This whole thing is my answer, and this is the exponent. I'm spelling bay. Now I'm going to go to b. So again, the base is the same. I take this exponent, goes here, and it equals the answer. Just like we did in 5-1, when the bases are the same, get rid of them, and then it's just x equals 4. And then the last property, whenever the log or the base of the log is equal to the same log with the same base, then these just cancel out, and then you're just left with x equals y. So let's say we had something like this. Let's say it was log base 3 of x equals log base 3 of 4, and it said solve for x. Whenever these logs have the same base, cancel them, and x equals 4. Solve for x, and we're going to use these properties. Now, some of them, all we're going to do is switch it from log into exponential, and then we're going to use the skills that we did in 5.1. So the first one, the main idea here is if you cannot solve this log without a calculator, then you need to try to change it to exponential. Then you could probably solve it. So on the test, you're going to get questions like this that you can solve for x without a calculator by converting it to exponential form. Now, some of the newer calculators do this problem. What we're going to learn later on is the change of base. If you just use the log button on your calculator, it assumes it to be in base 10. So coming up, I'll tell you how to use your calculator to do problems like this. But for now, all of the questions in this notes can be done without a calculator because we're going to transform them to exponential, and then we're going to use the skills we learned in 5.1. So let's go ahead and turn this into exponential. Remember, when it's in log form, it spells bay. So base, answer, exponent. To put it into exponential, I'm going to spell b now. So 2 is the base, x is the exponent, and 32 is the answer. Now I'm going to use my 5.1 skills. I'm going to do the change of base, and I'm going to change the 32 so it has a base of 2. So I'm going to change 32 into 2 to the 5th power. Now that they both have a base of 2, get rid of those 2's, and then now the final answer is x equals 5. Now, what you can do here is once you get this answer, you can take it and plug it in. If 2 to the 5th power did not equal 32, then you did something wrong. Let's try the next one. Again, we're going to transform it into exponential. Yes. This one, again, it's spelling bay, B-A-E. So 4 to the x power equals 2. Again, I'm going to do my change of base. So I'm going to change this 4 so it has a base of 2. I can change it to 2 squared. And now I can get rid of the 2's, the base. And now I have power to a power. Now on this 2 over here, I assume this has an exponent of 1. Power to the power, multiply them, set it equal to 1. Divide, and x equals 1/2. And if you think about it, if you take this answer and you plug it back in to the exponential form you just made, 4 to the 1/2 power, when it's a rational exponent, a fraction, this means we're really doing the square root of 4, which equals 2, which was the answer we were looking for. The next one, this is our property, but again, let's go ahead and put it into exponential, BAE. So 3 to the x power equals 1. Here's where you need to memorize that whenever you see the answer is a 1, you know this power is a 0. This is a property. Number 10, let's transform it to exponential. BAE, 10 to the x power equals 1/100. Soon as I see that I've got a fraction here, that's a clue that this is going to be a negative exponent. But again, let's change the base. This is really 1/10 squared. And I still need to make this have the same base. So I'm going to change 1/10 squared to 10 to the -2. And there should have been an x. Sorry, let me fix that. That was x. And now that I have the same bases, get rid of the 10s. And my final answer here is x equals -2. The next one, again, a property here. Let's go ahead and change it into BAE. BAE. Now, in the WebAssign tonight, it may ask you to simplify, and it may give you something just like this. It just may have log 6, 1, and it's going to ask you to figure out what that is. You can add in the equals x. So you can add in, do your Bay trick. So whenever it says to solve for, simplify it or solve for x, you can add in the x. So if it just has this, you can add the equals x to figure out what log base 6 of 1 is. So again, I'm going to do base is 6, exponent is x. Here again is where you're memorizing. Anything to the 0 power is 1, so x equals 0. So again, in the WebAssign, it'll probably have just this. If you want to do the Bay trick, add in the equals x. Now, if your question is given to you like this, let's say it was x equals log base 6 of 1. If you like doing that Bay trick, move the x to the back, and then you can do your Bay trick. So if the x equals is in the front, move it to the back, or whatever variable's in the front. Number 12, BAE. So 5 to the x power equals 1/125. Again, I'm going to use my skills from 5-1. I'm going to change 1/125 into 1/5 to the third. And then now I can make it the same, pull it out of the bottom, make it a -3. Now that the bases are the same, get rid of that base of 5, and x equals -3. Let's try another one. All we're going to do is do a bunch of examples, applying the properties, or just transforming it, putting it into the opposite form, and then solving. So let's try example 13. So again, it's in log form. I'm going to move it into exponential. And again, in the WebAssign, if it doesn't have equal x and it just says simplify that, you can add in the equals x to do it. So here, I'm going to BAE again. BAE. So 7 to the x power equals 343. Again, I'm using my 5-1 skills. I need to figure out how I can change 343 so it's a base of 7. I know that 7 to the third power is 343. Now that I have the same base, get rid of the base 7s, and x equals 3. Next one. Same thing, BAE, but this time I'm looking for a base, not an exponent. So this is like the stuff you did at the beginning of the year. So x is equal to, and here it's the exponent, is equal to 8 over 27. So what I need to do here is get rid of that exponent of 3, that cube, and to do that, remember you cube root both sides. I can cube root the 8 individually and the 27 individually, and x is equal to 2 over 3. Now, if that was a square root, I'd do plus minus, but since it's a cube root, it's whatever sign is there. But again, remember that base can never be negative. So even when we would be square rooting something to find a base, we would throw away the negative answer. Because again, this number that's here and the base, these can never be negative. The answer can be, but the base and the base of the log and the number that you're finding the log of cannot be negative. Let's try 15. Again, if in this form, BAE, so 4 to the 5 over 2 power equals x. Now, in this particular problem, I'm just solving 4 to the 5/2 power. And again, remember, when it's a rational exponent fraction, the bottom, this is the root, and the top of the fraction is the exponent. So what we should be doing here is the square root of 4 raised to the 5th power. Now, normally when we would do this, we would get plus and minus 2, and then here raised to the 5th power, but we don't want this number to be negative, so we're only going to keep the positive here. So then we're just doing 2 to the 5th power, and x equals 32. So again, the base of the log cannot be negative, and the number that you're finding the log of can't be negative. So let's look at the next one. 16, BAE again. So we're doing 49 to the x power equals the cube root of 7. Again, I need to use my 5.1 skills. I need to make the bases the same. Remember, when it's a root, I can change it to a fraction exponent, and then I can also change the 49 into 7 squared. Now that the bases are the same, get rid of the 7s, and here you're going to multiply this power to the power. It becomes 2x equals 1/3. And now I need to solve for x. You're dividing by 2, which when you're working with fractions, it's like multiply by the reciprocal. So really what I'm doing here is multiplying both sides by 1/2 to divide by 2. So then x equals 1/6. The next one. Same thing, we're going to turn it to exponential. BAE, 5 to the x power equals 1 over 625. I know that 625 is 5 to the 4th power. I can now make the bases the same by pulling that 5 to the 4th out of the bottom of the fraction and making my exponent negative. Get rid of the bases, and x equals -4. Again, once we got this x value, the answer here can be negative. Let's try the next one. BAE again. So again, if the question in WebAssign just looks like this, 0.01, and then it doesn't have anything here, you can add in the equals x, okay, when it says to simplify. So here it would be 10 to the x equals 0.001. Soon as you see that it's equaling a decimal or a fraction, that should be a clue that your exponent is going to be negative. So you can do two things here. You could either realize that this is 10 to the -3 right away. You could make it into 1 over 1,000. Either way, if you realize that 0.001 was 10 to the -3 power, you don't need to show this step. And again, cancel the bases, and x equals -3. So again, whenever you see that answer of the exponential is a decimal or a fraction, that should be a clue that your exponent is going to be a negative number. All right, we just have 6 more problems, and then that's it for as far as we're going to go today. I'll probably show you one little example of a graph, but we'll get more into the graphing tomorrow. Let's do some more examples. Some of these are going to use some of the properties now. So again, let's turn this into exponential. And let's go ahead and see how the x was in the front on this one. So on this one, if you want to use the Bay trick, move it to the back and put the equals x over here. So then now BAE, 8 to the x power equals the 4th root of 8. So here again, I'm going to turn this 4th root of 8 into a fraction exponent. Now my bases are the same. Get rid of the 8s. And the final answer is x equals 1/4. Now, we could apply our property here that we saw. If you realize that this answer here, we could do this, log 8, change the 4th root of 8 into 8 to the 1/4 power right here. And notice that these are both the same. The base of the log and the base of that exponent would cancel out, and then it goes right to x equals 1/4. Now this next one, even though you see the word log here, this is exponential form. The x is the base. So this is spelling b here. So this is the base. I'm sorry. Let me flip it around. Sorry. So this is 3 to the log base 3 of 8 equals x. So this is my base, this is my exponent, this is my answer. Now, we can do two things here. We could transform it into logs and show that one property, or again, if you recognize that when the base of the exponent is the base of the log, this just cancels and you're left with x equals 8. Now the other way would be to take the exponential. So let me rewrite it up here. Base 3, and this log base 3 of 8 is the power, equals x. So if you want to turn it back into log and spell bay, you could do log. And again, this is spelling B-E-A. So the base here is still the same. It's a 3. And then this will be an x, and it equals log 3 of 8. And that other property showed us that whenever This log base is the same. They'll cancel, and then you're just left with x equals 8. So you could use either property on this one. Same thing on this one. This is exponential. Again, if you recognize that this base of this exponent here has the same number of the base of the log, this cancels, and you're left with x equals 9. If you want to turn it into, we could flip it around. 2 log base 2 of 9 equals x. And again, this is spelling B-E-A. I could turn it back into log form and get that log base 2 to cancel. So now if I want to move it into bay, I can do that as well. Put the log, the 2, the answer, and then the exponent. Notice I could apply this property where I cancel the log base 2, and it goes right to x equals 9. So when we get into the more complicated log equations, you're going to be applying these properties a lot. Now the next one, we're solving for a base, not a power this time, but I'm still going to put it into exponential. So right now it's spelling bay. I'm going to put it into exponential. So 4, oh, I skipped one, sorry. Let me go over here. Same thing, BAE. So I'm doing x raised to the negative 2 power equals 25. I'm going to solve this as a proportion. So what I'm going to do is I'm going to go ahead and change this to 1 over x squared. And then put the 25 with the 1 underneath it. And now I'm going to solve it as a proportion. So I'm going to multiply 25 times x squared. And then 1 times 1. Divide by 25. X squared equals 1 over 25. Square root both sides. And x equals 1/5. Again, I don't want my base to be negative, so I don't keep the negative 1/5. And then next one where I started it. So again, BAE still. So again, I'm going to take the base, raise it to the 3rd power, and set it equal to x. Nothing to solve here. I just have to simplify what 4 to the 3rd power is, and that's 64. And then the last one of solving for x. Again, this is I'm gonna transform it again. If it's better for you to take the x and move it over here so you can do your BAE trick, we're going to be setting it up as 4 to the x power equals the cube root of 16. I'm going to change 16 and I'm going to make it to the 1/3 power. And now I need to do the change of base. I can change the 16 into 4 squared, but it still had the 1/3 there. Now that I have the bases the same, get rid of the 4's. And now I'm left with x is equal to, multiply this power to the power, to 2/3. So again, that completes solving for x and transforming from one form to the other. Tomorrow, we're going to be graphing the exponential functions. So tonight's homework is just to go back and forth between the two forms. And then tomorrow, I'll do a bunch of examples of graphing the logs. What we can do is transform them into exponential, and then we're going to do a t-chart. just like we did when we made the graphs for the exponential functions. But instead of plugging in numbers for x, we're going to plug in numbers for y. It'll make it a little bit easier. So tonight, your homework is 5.2a. If you did not do those 6 problems of 5.1c, make sure you do those as well. That is all calculator. 5.2a, no calculator yet. So that is it for part 1 of 5.2.